everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We started a discussion with almost all trigonometric chapters, right? Then we learned this mathematical induction. Today we are going to start a new chapter and one of the most easiest and simplest chapter, that is matrices. What is this matrix? Matrix, the term itself, the matrix is a singular term and the matrices is a plural term. Fine. What do you mean by the term matrix? Tell me. We have seen the different arrangement and series and sequence of elements in our previous chapter, right? Here, a matrix is arrangement of elements in an order. Okay, that is nothing. An arrangement of an element is called as array. Just simply remember. Then, the ordered rectangular array, ordered in the sense, whatever the positions in which we place the numbers, the position should be arranged in an order, right? And it should be a rectangular box, these kind of horizontal lines and these kind of vertical lines. Okay, how many places do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right, which means the horizontal places, how many horizontal places do we have? We have 3 horizontal places, right? What about these vertical places? How many vertical places we have? 4, right? The horizontal arrangement of an element is called as row. Is it fine? And the vertical arrangement is called as column. Can you understand the term, right? Row are horizontal arrangements and column is a vertical arrangement. Is it right? That's why whenever we do, whenever we tell dimensions of something, for example, rectangle will be L into B. Yes or no? Which means L is length, which is in the horizontal side. B is breadth, which is in vertical side. Is it right? This can be called as L by B. Right, in most of the measuring places we use the term as L by B but not as L into B, right? Is it not? Fine. Not only this, whenever you take some dimensions into consideration, okay, for example, if I take some object, some box, some plain sheet, right, we will have the dimension 24 by 32, which means 24 is the length and 32 is the height or breadth. Is it fine? Similarly, whatever the matrix, we always define in terms of row by column, right? This is called as an order, right? Mostly, see here, a row is always given by m by n, where m is the number of rows and n is number of columns. Okay, and a standard matrix is always denoted by capital letters and it is denoted like this. Okay, if I say some 2 by 2 matrix, what do you mean by 2 by 2? Bole to 2 rows and 2 columns. Let us say 1, 2, 3, 4. Is it not 2 by 2? Right? This is a standard notation of a matrix. Is it okay? See here. A matrix is given as 4 elements in which they are arranged in the form of 2 by 2. We will write like this here. Okay, and we always represent these numbers inside a square bracket. Okay, and this can also be generally notated as, if A elements are the elements in it, then this can be written as A11, A12, A21, A22. What does it mean? First row, first column, first row, second column. Okay, here second row, first column, here second row, second column. Is it right? Or this can be simply given as Aij, okay, where I belongs to 1 and 2, J also 1 and 2. Is it right? Did you understand till here? What all we discussed? What is a matrix? Its definition, then how to represent it, what is a row and column, what is its order, isn't it? Fine. Based on these things, we are going to learn this whole chapter. Right. Before going into that, let us know what are the different types of matrices. See here, these are all different types of matrices. Other than this, we can even define more and more matrices. Okay. See here, the first kind of matrix is a square matrix. You can easily tell when a rectangular can become a square. Tell me, if length and the breadth both are equal, then we can directly tell a rectangle as a square, isn't it? Fine. Now, based on that knowledge, can I define a matrix as a square matrix? Tell me how a square matrix can be a matrix when number of rows is equal to number of columns. Isn't it? Is it not the example of a square matrix? Yes or no? 2 by 2 matrix, right? Fine. Which means number of rows is equal to number of columns. Number of rows is 2 and number of columns is also 2. Fine. Did you understand? Clear. Whatever we solve in our whole chapter, we always solve 3 by 3 matrices, which means a perfect square matrix. So, better you have to understand whether it is a square or not, right? We can tell directly, yes, is it a square matrix? Actually, it is not a matrix. If I tell 3 by 4 matrix, is it a square? No, because number of rows is not at all equal to number of columns. Is that fine? Shall we move on to the next definition? See here. Second definition is diagonal matrix. What is this diagonal? Diagonal is this elements. Fine. Diagonal elements is the elements in which the row number is equal to column number. Is it clear? Which means, for example, if it is some fifth row, then fifth column element, right? Fifth element in the fifth row, or second element in the second row, first element in the first row. These all elements together form a principal diagonal, and such a diagonal and such a matrix in which it has only diagonal elements such as A11, A22, A33 and remaining elements as zeros. Fine. Such a matrix is called as diagonal matrix. Is it clear? Can you define what a diagonal matrix is? A matrix in which AII is not equal to 0. Fine. Other than these elements, that is 1, 1, 2, 2, 3, 3, other than these elements, remaining all other elements should be zeros. Clear? What was the first definition? Square matrix. What was the second definition? Diagonal matrix. Then let us see the third one. Scalar matrix. Scalar matrix is a square diagonal matrix in which all diagonal elements are equal, right? See here, a square matrix, scalar matrix is a square matrix in which all diagonal elements are zeros. Diagonal elements are equal, and we know that remaining elements are obviously zeros. Can you give me an example? 2, 0, 0, 2, right? Which means the principal diagonal elements are equal and the remaining elements are zeros. Fine. Can I define scalar matrix as a diagonal element matrix, right, whose elements are all equal? Isn't it? Fine. Next, unit matrix. This is again very, very important matrix. In standard, unit matrix is always denoted by capital I. Okay. Unit matrix is also defined as a scalar matrix in which these elements are unity. Okay. These elements are unity. Right. What is the order of this matrix? Second order, right? This can be written as I2 in standard. Then what about I3? 1 0 0 0 1 0 0 0 1. Isn't it? Which means except diagonal elements, all other terms are zeros and the diagonal elements are unit. isn't it? Did you understand about unit matrix? Fine. Then what is this null matrix? Tell me. Null matrix can also be called as zero matrix, which means all the elements of a matrix are zero, irrespective of its order, irrespective of its number of rows or columns. If each and every element is zero, then we can call it as a null matrix. Clear? And the last one more kind is row or column matrix, right? For example, if a matrix just have a single row, let us say 1, 2, 3 like this. How many rows does it have? 1 row and 3 columns. Such a matrix is called as row matrix. Then what about the column matrix? Can I call this as column matrix? Yes. How many rows does it have? 3 rows and 1 column. Therefore, I can call it as a column matrix. Is it clear? Is it not interesting and easy to understand? Fine. What all we learned? We started with the basic definition of matrix, right? Then order. Then we have seen the different types of matrices, in which, just look at here, square matrix is a matrix in which number of rows is always equal to the number of columns. Then the next, diagonal matrix is a matrix in which, except the diagonal elements, remaining all other elements will be 0. Scalar matrix is also can be called as a diagonal matrix in which the diagonal elements are equal and all other elements are zeros. Unit matrix is a scalar matrix in which the diagonal elements are 1 and the remaining elements are zeros. Null matrix is each and every element of a matrix is 0. Row or column matrices, row matrix is which consists of only single row irrespective of number of columns, right? A column matrix is a matrix which has only single column irrespective of number of rows. Is it clear? Shall we do few more things of matrices? Let's start. And the next definition we are going to study is triangular matrices. What do you mean by this triangular matrix? Triangle, we know that it should be, for example, if I say, if this is my rectangle, either this should be one triangle and this should be one triangle, isn't it? If I say this is a triangle, can I say it as upper triangle? Right? And what about this? This can also be lower triangle, isn't it? Fine. What is that which is dividing the whole rectangle into two triangles is a diagonal. Is it right? Can we use the same technique to define these? Yes, right? See here. In any matrix Aij, something like this, okay, if given by A11, A12, A13, A21, A22, A23, A31, A32, A33, right, in which if these three elements become 0, is it okay? Then this matrix can be called as an upper triangular matrix. How to define is, a matrix A is equal to Aij is equal to 0 for I greater than j. If you observe here, Ij, which means I greater than j, bole to 2 greater than 1, 3 greater than 1, 3 greater than 2. Except in these three elements, other than these three elements, remaining all other elements will be there. Give me an example for upper triangular matrix. Some 1, 2, 3, 4, 5. Some 6. Remaining three elements are zeros. Right? Then what about the lower triangular matrix? The matrix in which these three elements will be zeros. Then that can be called as lower triangular matrix. Just tell me, a matrix is Ai comma j is 0 for I less than j, then the matrix is said to be lower triangular matrix. Give me an example. 1, 0, 0, 2, some 3, 0, 4, 5, 6. Is it right? Did you understand these basic definitions? Fine. Let us move on to the next topic. Equality of matrices. When the two matrices are said to be equal, can we imagine? Just simply, the first thing, what is the first condition we have to check is the row should be equal. For example, A and B are two matrices. Then, first of all, we have to check whether the order of A is equal to order of B. Right? If yes, then each and every corresponding element should be equal. If I say A is a matrix A11, A12, A21, A22 and B matrix is B11, B12, B21, B22, right? Then the corresponding element should be equal. This should be equal, these both and these both. Then only we can tell these two matrices are equal to each other. Isn't it? Fine. And the next, sum of matrices. Right? Sum of matrices, again, what is the basic condition? That is, the order of first matrix should be equal to the order of the second matrix, and we have to add the corresponding elements. Right? If I want to add these two matrices, what will be my answer? Tell me. A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22. Is it clear? Just have a look in the mind that for equality of matrices and for sum of matrices, the order of the two matrices should be equal. Is it fine? Good. And the next, scalar multiplication. What is the scalar? Scalar is nothing but multiplying a constant to a given matrix. For example, if A is some, again, A11, A12, A21 and A22, then if I want to multiply some constant k, right, then it will be k into A11, k into A12, k into A21 and k into A22. Is it right? That's it. We have to multiply this constant to each and every element of a matrix. Is it clear? These are all the basic definitions and introductions and theoretical approach to a matrix. Clear? Shall we start doing the examples and the problems? Let's do. Look at the question here. He is asking us to add these both matrices. What is the condition? We have to check whether the order of the two matrices is equal or not. Fine. What is the order of the first matrix? How many rows do we have? 2 rows by how many columns? 1, 2 and 3. Okay. And here also 2 rows and 3 columns. Is it not equal? Yes, right. Therefore, we can directly add the corresponding elements. Okay. Just add it. 3 plus 4, 9 plus 0, 0 plus 2, 1 plus 7, 8 plus 1, minus 2 plus 4. This will be 3 plus 4 is 7, 9, 2, 8, 9 and 2. What's the order of this? Again 2 by 3. Whatever we get as a result of an addition will be the same as the matrices in the question. Okay. Look at the next question. What is the order of this? 2 by 2. Here 2 rows, 2 columns. This is also 2 by 2. Here also 2 by 2. Right. In this question he gave that the addition of these two is the third matrix it seems. Then let us write everything in the matrix form. A plus B is X. बोले तो -1 3 4 2 plus 2 1 3 minus 5 is equal to x1 x2 x3 and x4. Right? Yes, we know the order of the two matrices is equal. Then I can add the corresponding terms. Okay, that is -1 plus 2, 3 plus 1, 4 plus 3 and 2 minus 5 is equal to x1, x2, x3, x4. 1 minus 2 is 1, 3 plus 1 is 4, 4 plus 3 is 7, 2 minus 5 is minus 3. right? Now tell me, these two matrices are equal. बोले तो we have to equate the corresponding elements. x1 is 1, x2 is 4, x3 is 7, x4 is minus 3. Is it right? Is it not easy to solve? Yes? Fine. We have a few more problems on based on addition topic. Clear? Fine. This is for today. Let us meet in the next session with more problems of matrices. Thank you.